Ladies and gentlemen, allow me to take you through the formation of codes under probability. Okay, we'll look at the example and answer the questions that follow. The password of a computer consists of 3 letters and 3 digits. In that order, all 10 digits and 26 letters of the alphabet may be used. So, they are telling us that there is a password of a computer that consists of 3 letters. We understand that the total number of letters is 26, but the letters that will be used in this password is only three. Only 3 letters will be used in the password of this computer, and only 3 digits will be used out of 10 digits. Right. All 10 digits and 26 letters of the alphabet may be used. Considering this statement, they did not tell us whether the digits may be repeated or not. They didn't tell us whether the letters may be repeated or may not be repeated. So in a case whereby we are not given restrictions, then therefore the repetition is considered as allowed. Okay. Now, we have a question number 1. How many different passwords can be formed out of the 10 digits and 26 letters? Okay, and we are given the order of arranging these letters and these digits in that password. Then the second question, calculate the probability that the last letter of a password formed is a vowel and the last digit of a password is a factor of 9. Okay, let's start by answering question number 1. We put 3 dashes there. Those 3 dashes, those blue dashes, they indicate the 3 letters of the alphabet that form part of the password. Then the next 3 dashes indicate the 3 letters, the 3 digits that will be used in the password. So now we are using the dash method. Remember the rule of the dash method, which says that between the dashes there must be a multiplication sign. Then therefore there is the multiplication sign between the dashes. Okay, let's start now with the letters of the alphabet. So here we have 26, 26 and 26 because repetition is allowed. In this case, we consider the repetition of letters as allowed since we haven't been told whether they are repeated or they are not repeated. So in that case, we consider the repetition of letters as allowed. Same applies to the digits. We consider the repetition as allowed because no restriction has been given. Then therefore, how many digits are we using in this formation of the password? We are using 10 digits, and that we have 10, 10, 10. Then how many passwords are possible in this case? Then therefore we have 17,576,000 possible passwords that may be formed in the case of having 3 letters and 3 digits. And a repetition of letters and digits is considered as allowed in this case. Right, let's consider now coming to question number 2. Calculate the probability that the last letter of a password formed is a vowel and the last digit of the password is a factor of 9. Right, let's use the dash method. Those are the first 3 dashes that represent the 3 letters of the alphabet, following by 3 dashes representing the 3 digits. Following the rule of the dash method, which says that between the dashes there must be a multiplication sign, then therefore there is a multiplication sign. Now you see in the first and second dashes there is 26 and 26. Why? Because there is no restriction given for the two positions. But now it says that calculate the probability that the last letter of a password form is a vowel. So we only consider the last position in the vowels of the letters. So what is happening there? Not any letter will occupy that position. It will only be occupied by a vowel. How many vowels do we have in the letters of the alphabet? They are all 5 vowels. Then therefore, meaning that that position can only be occupied by vowels, and we have 5 vowels. That's why we are having 5. Right, we are done with the letters. Let's move on now to the digits. You see 10 and 10 because the first two positions in the letters, there's no restriction. But now coming to the last one, it says that and the last digit of the password is a factor of 9. What is a factor? A factor is what are the factors of 9? Factors of 9 are numbers that two numbers that you multiply and then you get the product, which is 9. So what are the factors of 9? When you multiply 1 and 9, you get 9. Then therefore 1 and 9 are the factors of 9. When you multiply 3 by 3, then you get 9. Then 3 and 3 are the factors of 9. Therefore, how many factors of 9 do we have in total? Is 1, 3, and 9. So we have 3 factors of 9. In those 10 digits, 3 of those digits are the factors of 9, which is 1, 3, and 9. Then therefore there are only 3 digits that can occupy this last position in the digits. So now what is the total number of password formed whereby the last letter is a vowel and the last digit of the password is a factor of 9? Then therefore there will be 1,014,000. That is the total number of password whereby the last letter is a vowel and the last digit is a factor of 9. Now let's calculate the probability. Probability will be equal to the total number of passwords whereby the last letter is a vowel and the last digit is a factor of 9 divided by the total number of passwords formed whereby there is no restriction. Then we need to simplify this to 3 over 52. This is the probability required.